This is number 30, assignment C, Z-test for men. It says, John claims that the maximum score that Math 1-to-1 students can achieve is 75%. You are given the task of testing the above claim by first completing topic, research question, hypothesis in symbolic form, and objective. So let's get the topic and so forth. So the topic there can be students' score. So the research question here will be, what is the average score of the Math 1-to-1 students? The claim is saying that the Math 1-to-1 student score is 75%. So that is the claim in worded form. Now we have to translate this now to symbolic form. The symbol for is the equal sign. So therefore now the translation of is equal. And since this sign carries the equal sign, well, this is the equal sign actually, so it will be a null. And to complete the pair now, the alternative will be the not equal sign. So that will be steps number 1, 2, and 3 to complete to start the hypothesis test. Let's go to the objective. So the objective will be to determine the average score of the Math 1-to-1 students. Now let's go to the steps to perform a Z-test for mean critical value approach. As you can see, the first step says to translate the hypothesis to mathematical form, which we did. Second step says to identify whether it is a null or an alternative, which of course we did. The third step says to complete the pair, which we did. Okay, so we have accomplished steps number 1, 2, and 3. Here, as you can see, the alternative for equal is the not equal sign. Now let's go to step number 4. Step number 4 says to sketch a distribution curve. Since it's a Z-test for mean, it will be a normal curve, a bell-shaped curve. Step number 5 says to shade the critical region. The critical region can be a one-tail or a two-tail. For a Z-test for mean, the critical region follows the direction of the sign of the alternative statement. The sign of the alternative statement can point to the left, right, or both directions. If the alternative statement pointing towards the right, the critical region will be on the right. If it's pointing towards the left, the critical region will be on the left. If the sign of the alternative is a not equal, then you'll have a two-tail. Let's look at our sign of our alternative. Our sign for our alternative is a not equal, so we have a two-tail test, like always indicated. We can use our snipping tool and take a snapshot of this here and paste it in our working. That will be steps number 4 and 5. So we paste this right there, paste it in drawings, and that will be steps number 4 and 5. Let's go to step number 6. Step number 6, remember, it says for the Z-test form in the rejection region will always follow the sign of the alternative. Please remember that. Step number 6 says to place the critical value on the critical point. The critical value will be provided. The critical value here is negative 1.96. So since we have a two-tail test, our critical value will appear twice. One on the left, negative 1.96. Zero in the middle. And one on the right, positive 1.96. Because on the right side of 0, we have only positive numbers. So let's go to step number 7. So here's the formula to calculate the z-test statistic. That's step number 7. It says x minus mean, x bar minus mu, sorry. Our x bar will be our sample mean and our mu will be our population mean. The sample mean is 78 and the population mean is 75. So it will be 78 minus 75. Divided by sigma over the square root of n. Sigma is 7.6, n is 100. So we have calculated the test statistic, a statistic to test a hypothesis, and get it a value of 3.94. So let's go to step number 8. Step number 8 says to plot the test statistic on the distribution curve. You must look at the value of the critical value that is there already in order to plot the test statistic on the correct position on a number line. So when you go to our number line, we are seeing that 1.96 is there, and we have to plot 3.94. Okay, so clearly 3 is greater than 1. So we can put 3.94 anywhere around this region. Let's put a point, color code, where the test statistics is. And we can clearly see the test statistic at step number 8 is in the critical region. So let's go to step number 9. Step number 9 says reject the null if the test statistic is in the critical region. All right, do not reject the null if it is not in the critical region. When we look at our test statistic, it is in the critical region. So for step number 9, we have to reject the null. So that's basically what you type. Reject the null hypothesis, which is HO. And we go to step number 10 now. Step number 10 says, if the null is rejected, then the alternative is the conclusion. If the null is not rejected, then the null itself is the conclusion. When we look at what we did, what we decided to do, we decided to reject the null. Okay, so therefore now, since we have rejected the null, we have rejected that statement, then the alternative is our conclusion, and we have to quote it in words. The mean is not equal to 75. Okay, actually, we claim 75, but we got 78. 78 is significantly different from 75. And that was proven to be true. So you always begin by saying, based on the data, and we quote the alternative hypothesis, which is saying that the average score is not equal to 75%.